Hey grade 12s, I welcome you to this maths clinic. This is a segment where you're going to find a lot of help in terms of mathematical problems that you're encountering in certain topics. And this video is presented by the maths doctor, Zewamo and Mofire. Okay, so today we are looking at earth geometry. And under earth geometry, what you have to understand first and foremost is that this is one of the topics that always comes in an exam. And studying earth geometry, you can never go wrong, because in both paper 1 and paper 2, questions do come under earth geometry. Okay, so to start with, let's look at what earth geometry is all about. Therefore, in the meantime, you can get a pen and a paper and get prepared to write some of the important points that you're going to get from this presentation. Okay, now earth geometry is a topic which is concerned with the location of places, calculation of distances, and determining time differences between places on the Earth's surface. Generally, in mathematics, the Earth is taken to be a sphere, and it is assumed that it has a smooth what? It has a smooth surface. So, having that in mind, we're going to look at some of the words that are very important in as much as earth geometry is concerned. We've got keywords such as latitude and longitudes. Okay, so these keywords are very important to understand if you are to get the concepts in earth geometry. You have to understand what is the meaning of the latitude and what's the meaning of the longitude. Not only that, we'll also look at certain keywords that are associated with the okay, so from here we've got the eastern hemisphere, then from Greenwich we have the western hemisphere. You start from 0 degrees going this side. You also start from here 0 degrees going this side. Now, what are those degrees that we're talking about? Those degrees are the angles from the center of the what? From the center of the Earth. So when you're saying this is 0 degrees, it means when you are coming from here to any of these points, you see, 0 degrees. When you're coming from here to this point, this is the starting point. So when you move to this side, you are going to the west. From here, you come this side, you are going to the east. That is what we mean. So from the center of the Earth, when you come direct to this point, it means you are starting now from 0. Then from here, you come straight to this point, which is the equator. You're making an angle here. And this angle is measured from 0 going this side to the eastern side. Okay. So let's look at the latitudes. Latitudes, as we have said, we have the lines that run from west to east, and among the latitude that we have the equator. This equator is also called the Great Circle, and by definition, a great circle are all imaginary lines. And remember that all these lines do not exist on the Earth's surface; they are just imaginary lines. So, a great circle, by definition, is a circle whose center is the center of the what? Of the Earth. So, any circle on the Earth's surface whose center is the center of the Earth is called a great circle. Now when you look at the latitudes, you only have one line, or you only have one circle, which has the center of the what? The Earth. When you look at this one it's the center is not the center of the Earth. So meaning this is a small circle. Also, we have other small circles or latitude that we have not shown here. So meaning the latitude, there is only one great circle. But when talking about the longitudes, all longitudes are great circles. Why? Because they pass through the North Pole and the South Pole. All of them. When you are coming from this one, it comes here, then it goes on the other side of the Earth, and then coming back to pass here again. I hope you understand. So the equator is 0 degrees. It divides the Earth into two hemispheres, the northern hemisphere and the southern hemisphere. Remember, those two hemispheres that I've mentioned, take note of those words. So we have the northern hemisphere and the southern hemisphere. We're going to use those hemispheres later. And we also have from here, from Greenwich, we have the eastern hemisphere, we have the western hemisphere. So those are some of the points that you should take note from here. Okay. Now, let's move on to how do you name positions on the Earth's surface. Remember, that is one of the objectives of studying Earth geometry. You're supposed to locate places. Now, for you to locate places, you need to know and you need to name certain positions on the Earth's surface. Okay. Okay, so just take a look at the illustration of the Earth, which is spherical in nature, as I have said. So as you can see, we've got these lines that run from north to south. Then we also have lines that run from west to east. Now, in order to define or understand these two keywords, we're going to define by the illustration that we've been given. So let's start with the latitudes first. Now, the lines that run from west to east are called latitudes, and then the lines that run from north to south, they are called longitudes. Now just there, we also have very special lines. On the longitudes, we have got a special longitude that is called the Greenwich meridian. Now, all longitudes are also called meridians, but this one has a special name, which is Greenwich meridian. And this is the line that is used to measure all the other meridians. Now, what does that mean? It means when you start looking at the angles from here going to the east, you start from the Greenwich meridian. And also when you're going to the west, you also start from the what? From the same Greenwich meridian. Okay. So naming positions on the Earth's surface. So as you can see this diagram, it shows the Earth, which is spherical in nature, as we have said. We have the North Pole here, then we have the South Pole here. Okay, then we have the center of the Earth, then this is the equator, it comes here and then it passes on the other side of the Earth, making this O here point to O as the center of the Earth. Now from the center of the Earth, there are angles that are formed here. Now as I have said, I've said from here to here, this is the measuring. This is where you measure angles from B. Okay, now what questions can be asked based on this diagram? Let's look at the question so that we understand this better. In the diagram above, the semicircle, okay, the semicircle NHBES. This is a semicircle. It divides the earth into two equal halves. We have the eastern and the what here? We have the eastern and the western hemisphere. Okay, so this is the semicircle, and it is the what? It is called the Greenwich meridian, as we have said. So the points A, B, C lie on the equator. So we have this point, we have this point, we have this point, which lies in the equator, and the equator is 0 degrees. It also measures the what? The latitudes from here. You can either go to the northern or you can go to the southern. Okay, it also forms angles from here, from the center of the what? The earth. Okay, now calculate angle A or B. Where is angle A or B? A or B? This angle here. What is this angle? Now, before we calculate the angle, let me make mention 2 points that are very important. Now, if you are calculating, if you want to find angles on the Earth's surface, from the center of the Earth to any point on the Earth, the first thing that you need to understand is that when you are moving from the same hemisphere, let's take for instance you are working on the western hemisphere, and all the angles that you're finding are from the eastern hemisphere, like this one. It means you subtract the the difference that you have in terms of the longitudes. Okay, so you're moving, we have two different longitudes, we have this one, we have this one. So that is remember that these 2 points lie in the same equator, so you can't find the difference in the equator to be 0 because this whole thing is 0. So you have to find the difference in terms of the 2 points, which are the longitudes, this point and this one. That is the angle that you're going to get here. So you subtract same hemisphere. Same applies to the eastern hemisphere. If you are working from the same eastern side, all points are on the eastern, you subtract as well. But what happens if you're finding the other point is A, the other one is C, and you're finding this angle? So since they are from the different hemisphere, the other one is on the eastern, the other one is on the western, you have to add these two differences. Okay, this longitude, which is this one, 20 degrees east, and the one which is 40 degrees west, you add these two to find the angle here, which is A or C. As simple as that. So the most important thing to understand are those 2 points. If you're working from the same hemisphere, subtract. If you're working on different hemispheres, you add. Okay, so we have said A or B. Is A or B. So the angle that you're finding here, subtract this longitude, because the latitude is the same, which is 0. So you're subtracting this minus this, which is this one is 0, this one is 40 degrees west. So 40 degrees west minus 0. That is how you do it. So first, I've said you identify the point. So the point A is latitude 0 degrees, then longitude what? West, 40 degrees west. So this is the point A. Okay, 0 degrees, comma 40 degrees, which is the longitude. Then point B is on 0 degrees, 0 degrees. Remember that point B, it lies, longitude is 0, latitude is 0. So that's why both points are 0, 0. Okay. Then the difference now, this one is automatically 0. So we are finding the difference in terms of longitude, 40 minus 0, which is 40 minus 0 is 40 degrees. Then we have the second question where we are finding angle BOC. Where is BOC? We have BOC. So the same applies to this one, from 0 to C. So same, you are subtracting. So this longitude is 20 degrees east. So 20 degrees minus 0. So the point is the same. So B is 0, 0. Then C is latitude 0 degrees, longitude 20 degrees east. Okay, that's the point. Then you subtract. And then 20 degrees minus 0 is 20 degrees. Okay. So we have another question where we're finding angle AOD. Okay, let's see. AOD. Okay, so we're finding this angle here. Now, you have to be careful here because now it has changed. You are no longer finding the angle in the same line of latitude. You're finding angles now in the line of what? Longitude, which is AD. So AOD, which is this angle here. Now what happens here when you're finding this angle? It means since they lie in the same what? Longitude, which is okay, so we've been told to find the angle AOB. So as I have said, from 0, you're coming from the west, A or B. So if you're coming from the west up to B, this angle here, remember that angles are measured from B. So since this is west, so meaning you are supposed to subtract. So you subtract the difference in terms of longitudes. Now first you have to identify point A. Now how do you name a point? You name a point in terms of latitudes and longitudes. Just the same way you name a point in the Cartesian plane when you're talking about x, y. For example, if you say x, y, so x is the x-axis in the horizontal, then the y-axis is the one which is vertical. So the same way you name on the Cartesian plane, that is how you name points on the Earth's surface as well. So the x-axis in this scenario is the latitude, the y-axis is the longitude. So meaning point A lies in the 0 degrees. Remember 0 degrees is neither east nor west. So just say 0 degrees, comma, and always the point is separated by a comma. So 0 degrees, which is latitude, comma, what is this point? Is 40 degrees west.